Okay, we're going to be looking today at another rule in probability. We've been looking at the AND rule. Now, with the AND rule, you have two times. We're going to be looking at OR rules. Now, but to start off first, if A and B are mutually exclusive events, so then the chance of A or B happening will be chance of A happening separately plus chance of B happening separately. Now, the first thing you need to do is to think about what mutually exclusive events are. Now, mutually exclusive events are events that can never happen at the same time. If one happens, the other one cannot. For example, let's say, for example, in year 7, I've got 10 students. And then in year 8, in a school, I've got 20 students. Now, let's pretend that that's the only, these are the only students we have in the school. It's only year 7 and year 8. There are 10 in year 7 and there are 20 in year 8. So the chance of a student being in year 10 would be then 10 out of 30. And the chance that a student is in year 8 is going to be 20 out of 30. Because altogether in that school, I've got 30 students. So 10 plus 20 is 30. Now, a student cannot be in year 7 and cannot be in year 8 at the same time. That's one we need to agree. The student cannot be in year 7 or year 8 at the same time. It means these two chances are basically mutually exclusive. If one happens, the other one can't. You are either in year 7 or in year 8, not at the same time. Now, if I pick one student at random, what's the chance that that student is going to be either in year 7 or in year 8? I've come to that school and I've just picked one student at random. Now, the chance that that student is in year 7 or 8 is going to be 1. It's going to be whole thing because anybody picked at random must either be in year 7 or year 8. That's definite for that school because all the kids there are either in year 7 or year 8. So I'm sure that the chance of a student being in year 7 or 8 will definitely be 100%. Okay. Now we add their probabilities separately. You just add, or means you add their probabilities separately. Okay, and that's just it. Because that's what it say here. Probability that a student is in year 7 or in year 8, A or B, is given by probability of being in year 7, A, plus probability of being in year 8, B. Okay? Chance of being in year 7 is 10 out of 30. And chance of being in year 8 is basically 20 out of 30. Now, when you're adding fractions, you only add the top one as long as the bottom one is the common denominator. So 30 out of 30, which is basically 1. And that's whole 100%. So definitely a student will be either in year 7 or year 8 in that school. So for mutually exclusive events, all you need to do, you just basically add their probabilities if you want to see the chance of one happening or the other one happening. Okay. Now, what about if these two events you're talking about are not mutually exclusive, which means that they can happen at the same time? Okay. So say, for example, if in a class I've got, let's say I've got students who are doing English in a class. In a class, I've got students who are doing English being 10, and students who are doing, say, for example, Spanish, and say, for example, 5. Okay, that's one thing I want us to understand. Now, and also students who are doing English and Spanish. So that's going to be English and Spanish. Now, this sign means and, but let me just ignore it. I just use the word and. So it's doing English and Spanish. It's doing both basically. Okay. Now let's pretend I've got say 3 students who are doing that. Now what that means is this: that out of these 10, 7 of them are just doing English only, and 3 are also doing Spanish. And likewise here, it means that 2 are the ones that are doing Spanish only, the 3 are doing English as well. So this one's here. These 3 here we're talking about is what this one is. Okay. So those who are doing English only are 7, and those who are doing Spanish only are 2. But those who are doing English, if we count all of them, are 10, because we know that these other 3 are also doing Spanish. Okay, so what's the chance that a student picked at random is doing English or Spanish? Okay, what's the chance that a student picked at random is doing English or is doing Spanish? Okay, again, what we are sure is that The chance that a student is doing English or Spanish here is going to be basically 1 because a student is either doing English or Spanish or even both. So we know that that's going to be 1. Now this given by this chance here. The chance that a student is doing Spanish is basically 10. That one there. And the chance that a student is doing Spanish is 5. But you see, there are those students that we counted twice. These 3 have been counted twice. When you say this 10, the 3 were already there. And again, when you say this 5, the 3 are already there. So you need to take 1 3 out because you can't add twice. Okay? The 3s are hiding here and hiding here as well. So take one of them out. You don't need to add them twice. Okay, so we got 15. 10 plus 5 minus 8. So 10 plus 5 is 15. 10 plus 5 is 15. Minus 3 is basically going to be 12. So basically, the number of students in this class actually is just 12. 7 who are doing English only, 2 who are doing Spanish only, and then these 3 who are doing both English and Spanish. Okay, you can look at them here. So 7 plus 2 plus 3 will basically be, that should be 7 plus 2 plus, that should be 12 here. There you are, that's 12 there. Now, so what are we saying? We are saying that if 2 events are not mutually exclusive, in other words, they can happen at the same time. If you want to see the chance of one happening or the other one happening, you just use this formula here. The chance of one happening plus the chance of the other happening, take away the chance that they're both going to happen because they can happen at the same time. Like a student can do English and Spanish at the same time, right? So you just take that one out as we've looked here. Okay. Now what I want you to do now is to pause the video and try that question. So pause the video and try that question. Okay. Now, so the first spinner shows is spanned once. What is the probability that it lands on a 2 or a shaded sector? A 2 or a shaded sector. Now, the first thing you need to understand is that if it's been spanned once, then it cannot land on a 2 and on a shaded sector at the same time. It's impossible. So these events are basically mutually exclusive. Now, with the mutually exclusive events, to find the chance of one happening or the other one happening, you just add their probabilities because they are mutually exclusive. Okay, they can't happen at the same time. So the chance that is going to land on a 2 will be 1, 2, 3, 4, 5, 6. So we got 6 twos, and the chance that's going to land on a shaded area will be 1, 2, 3, 4, 5. You focus on the shaded area will be 5. Now, when you use the word or, you just add them up. Now we need to think about the bottom number here. The bottom number is basically counting everything, which is basically 10. So if you have to count all these sections together, there are 10 sections. Okay, the chance of landing on a 2 is basically 6 because there are 6 twos, which is this one here. And the chance of landing on this is going to be that. Now, they say that the first spinner shown is spun once. What is the probability that it lands on a 2 or a shaded sector? Now, the spinner can land on both 2 and a shaded sector at the same time, so they are not mutually exclusive. Wow, this is really, I don't know why, so I don't know why they said that. Because if you're spinning this, I've not looked at this earlier on, sorry about that. If you look at it, let's say for example, you're spinning this spinner. Right, sorry, well, I really do apologize about this question. I've not looked at this spinner properly, so I'm just going to look at it properly again. Now, what I've just realized is that, 2 and a shaded area can happen at the same time, so it's my fault. So if you look at this one here, I can see that in this section here, the spinner can land on a 2 and on the shaded part at the same time, and this as well. Okay, so that's, I do apologize, I didn't look at it properly. So they are not mutually exclusive events, which means that they can happen at the same time. Okay, if that's the case, then we're going to use the second equation we had, which is this one here. Because they're not mutually exclusive events, they can happen at the same time. You add their probabilities and you take away the probability of both of them happening at the same time. Now, coming to this, you can see that the chance that a spinner is going to land on a 2 would be 6, right? So 1, 2, 3, 4, 5, 6. So 6 out of 10. And the chance that it's going to land on a shaded area shaded areas are 1, 2, 3, 4, 5. So 5 over 10. Take away the chance that it's going to land on a 2 with shaded area. Now, 2 unshaded, that's 1, and that's 2 there. Okay, so that's going to be 2 out of 10. You take away that common one, and the answer is 0.9. Okay, so that's how to do that question.